All right, ladies and gentlemen, let's look at factoring when A is not 1. Let's take one more day to get this practice in because it's super important that we have this down. So here is my first example. If you notice, the coefficients of each of these terms are factors of 5. So that means I can actually factor out a 5. So I'm going to have 3x squared minus x minus 2. So in this case, what I'm able to do is factor out a 5. So let me go ahead and I've drawn my box in my x puzzle. Let me fill in my first and last terms. So I'm going to be using 3x squared and minus 2 as my first and last terms, not the original because we've factored out the 5. Now I'm going to go ahead and set up my x puzzle. So 3 times negative 2 would be a negative 6, and then my sum is a negative 1. So if I need factors of negative 6, so we have negative 1, positive 6. We have positive 1, negative 6. We have negative 2, positive 3. And we have positive 2, negative 3. So I need my sum to be a negative 1. So it looks like this is going to be our best bet. So we're going to have a positive 2 and a negative 3. So when I go to fill this in, I'm going to have a positive 2x and a negative 3x. Okay. So as I trek along here, I'm going to take out my greatest common factor of that first row. I know I can take an x out, and I can take a 3 out of that one. So then in that first column, I'm left with an x here. So that piece is done. So if I'm factoring out an x, down here below, I'd have to factor out a 2. But I also have the negative 2 here, so let's take it out as a positive 2 and see what happens. Now let's go ahead into that next one. If you notice, they're both negative, so that means I'm likely going to have to factor out a negative 1. So in this case, we have 5 hanging out up front still, 3x plus 2 times x minus 1. So let's check this. So this will be 3x squared minus 3x plus 2x minus 2. Again, we still have that 5 hanging out. Let me combine my like terms. So 5 times 3x squared minus x minus 2. So then this would become 15x squared minus 5x minus 10. That's exactly what we need it to be. So then my final answer is this one here. So 5 times 3x plus 2 times x minus 1. All right, here's another. So we are going to continue to solve this. First of all, I have no greatest common factor. I'm going to fill in my first and last term. So I have 10q squared and then a positive 2. So for my x puzzle, I have 20 and 9. So my factors of 20 would be 1 and 20, 2 and 10, 4 and 5. So to get a sum, I'm going to have to use positive 4 and positive 5. I like it when it's all positive. It makes it a lot easier on us. So I'm going to have 4x here and a positive 5x here. So I guess we can start with, let's start with our row. So this first one looks like it's going to be and I put an x out of habit. I'm sorry. 4q, q. All right, so it looks like that first row, we're going to have to factor out a 5q. The second one, we're going to have to factor out a positive 2, it looks like. Now the columns, I'm going to have to multiply this times a 2q, which makes sense because 5 times 2 is 10, 2 times 2 is 4, so that gives us what we need there. And then it looks like this is just going to be a plus 1. So my binomials are 2q plus 1 and 5q plus 2. So when I multiply, I have 10q plus 4q plus 5q plus 2. So combining these middle terms gives us the 9q we're looking for. So that means this has to be our factors of that trinomial. All right, so when we're talking about the area, remember area is length times width. So in this case, that's all we're doing is finding those dimensions using two binomials. So it's not going to be values, it's going to be two binomials. So when I go to fill this in, I start with my first, my last. My X puzzle, this is going to be a -14 and this is a -13. Hopefully you're getting the hang of this X puzzle. That's probably the trickiest part of this. So I need factors of -14. So we have 1 and 14, 2 and 7, and of course positive and negative versions of both. So the one that would have to work would be this. And in order for it to be negative, it would have to be a -14 and a +1. So positive 1x, and I'm just doing that for now, and then a -14x. First column, I'm factoring out an x. For the second column, it looks like I'm going to factor out a -7. But let's see what we can do on those rows. So this looks like 2x, makes sense. And this looks like it's, let's say +1. So when I go to write these guys out, I have x minus 7 times 2x plus 1. So 2x squared plus x minus 14x minus 7. Combining my like terms, I have 2x squared minus 13x minus 7. All right, last one. It looks like we're going to have a greatest common factor in this case, and I'm willing to bet it's a 3. So let's see here. We have 3 times 6x squared minus 11x plus 4. That makes it a little more user-friendly, of course. Filling in my first and last terms, I have 6x squared and then a plus 4. Setting up our x puzzle. See, 6 times 4 is 24. And then -11. So for my x puzzle, I need a negative sum, but a positive difference. So that means everything's going to be negative. So this will be -1, -24, -2, -12, -3, -8, -4, -6, and I think that's it. So it looks like -3 and -8. So I have -3x, -8x. Now when I go to factor, remember you could do rows or columns. So when I start with my first row, it looks like I'm going to factor out, let's go with a 2x. So that means here this would have to be 3x, right? Because 2 times 3 is 6 and x times x is x squared. So then down below here, this would have to be a -1. So in order to create that here, it looks like we would have to do a -4. So let's check this. So, you know, at this point, this is what we're doing. We're kind of guessing and checking to make sure, I cannot write, to make sure that we're on track here. So we have 3x minus 4, 2x minus 1. So 6x squared minus 3x minus 8x plus 4. There it is. All right, so then 6x squared minus 11x plus 4 gets us that original one, and of course everything is times 3. I forgot the 3. So then when we finish, this is what we're left with.